Namaskar, hello, and once again a very warm welcome to this webinar series Listening to Learn यानी सुने और सीखें। मैं हूं तन्वी खुराना और इस वक्त आप हमें देख रहे हैं ई विद्या चैनल नंबर 9, 10, 11 और 12 पे। Department of Education in Science and Mathematics NCERT brings you this National Student Outreach Program, that is Pravasi Bharatiya Academic and Scientific Sampark. This particular program integrates Indian diaspora with its motherland. आज जिस विषय पर हम बातचीत करने वाले हैं वो एक शब्द है, एक टर्म है, पर मामूली नहीं है, ज़ीरो, जिसे हम हिंदी में शून्य भी कहते हैं। ये जो हमारा सीरीज़ है ये है सेशन नंबर 59 और बेहद ख़ास है क्योंकि ये टर्म की एक हिस्ट्री है। क्या हम इसे एज अ टर्म देखते हैं, क्या हम इसे एज अ मैथमेटिकल फिगर देखते हैं? आपको इस सब के बारे में जानकारी मिलेगी हमारे आज के मेहमान से। अगर आपके पास कोई सवाल हैं इस विषय से जुड़े हुए तो हम तक ज़रूर पहुंचाइए। यू कैन सिंपली कॉल अस ऑन आवर नंबर विच इज़ 8800040559। At this moment, you're watching us on NCERT Official, that is our YouTube channel. उसके लाइव चैट बॉक्स में आप अपने सवाल लिख सकते हैं। 11 बजे तक हमारे मेहमान हमारे साथ रहेंगे और आपके सवालों के आंसर देने की पूरी कोशिश भी की जाएगी। हम बताना चाहेंगे आपको कि it's been almost 2 years since this program started and we have covered a lot of topics related to science. और अगर आप चाहते हैं कि आपकी कोई चॉइस का टॉपिक यहाँ पर शेयर किया जाए, बातचीत की जाए, तो आप उनके सजेशंस, एडवाइसेस, फीडबैक जो भी आपके पास है वो ज़रूर भेजिएगा। NCERT Official is our YouTube channel. This is not an ordinary program. This is an outreach program. अगर आप कहीं भी बैठे हैं दुनिया के किसी भी कोने में, all you need is an internet connection and you can watch this program. This is going to be a very interesting session, I guarantee you that. So let me please introduce you to the guest of our today's program, and he is Dr. Mayank Vahia. Sir, a very warm welcome to you.
Thank you very much.
And with us, you can see on your screens sitting Dr. Gagan Gupta. Sir is the brain of this entire program. He is the coordinator. He is from Department of Education in Science and Mathematics, NCERT. So thanks to Dr. Gagan Gupta, we are able to arrange this entire program on this particular टॉपिक दैट इज़ ज़ीरो। आपके सवालों का हम इंतज़ार करेंगे। इससे पहले कि हम ये बातचीत शुरू करें, आपको बताना चाहेंगे वी आर एक्सट्रीमली प्राउड ऑफ द फैक्ट दैट इंडिया assumed G20 presidency and would convene the G20 Leaders Summit for the first time in the country this year, that is 2023. A nation deeply committed to democracy and multilateralism, India's G20 presidency would be a watershed moment in her history as it seeks to play an important role by finding global pragmatic solutions for the well-being of all, and in doing so manifest its true spirit of Vasudhaiva Kutumbakam, or should I say the world is one family. Vasudhaiva Kutumbakam also translates to one earth, one family, one future. And that is exactly the theme of this year's India's G20 presidency. मैं रिक्वेस्ट करूंगी डॉक्टर गगन गुप्ता से, सर हमारे आज के गेस्ट डॉक्टर मयंक वाहिया को सर हमारे सारे दर्शकों से एक छोटा सा इंट्रोडक्शन दीजिए और जो हमारा आज का टॉपिक है उससे भी थोड़ा सा परिचय करवाइएगा।
नमस्ते तन्वी जी एंड धन्यवाद एंड नमस्ते दोस्तों। आज मैं एक बार फिर से आपके साथ अपने 59वें सेशन में 59 सेशन में आपके सामने हूं और अपने साथ लाया हूं मैं अपने दोस्त और अपने सीनियर प्रोफेसर डॉक्टर मयंक वाहिया, जो कि डिपार्टमेंट ऑफ टाटा इंस्टीट्यूट ऑफ फंडामेंटल रिसर्च से हैं। और इससे पहले कि मैं प्रोफेसर वाहिया का आपके साथ तारुफ कराऊं, आपकी मुलाकात कराऊं, मैं कुछ सीरीज़ पर बोलना चाहता हूं। दोस्तों, अगस्त 2021 में ये सीरीज़ शुरू हुई थी, 2 साल अब पूरे हो रहे हैं आज। और इस प्रोग्राम में हमने साइंस एंड टेक्नोलॉजी से जुड़े हुए बहुत सारे विषयों पर बात की है दोस्तों, और चाहे वो मेडिसिन से जुड़े हुए हों, चाहे वो एस्ट्रोनॉमी से जुड़े हुए हों, चाहे वो फिजिक्स से जुड़े हुए, बैटरी से जुड़े हुए हों, एट्सेट्रा एट्सेट्रा। इससे पार भी हम गए हैं कई दफ़ा, हमारे भी पंख लगे हैं कुछ बार और पंख हमारे आगे लगते रहेंगे। हमने पोइट्री पर भी बात की है, इंडियन एंटरप्रेन्योरशिप पर भी बात की है। हमारे साथ एक आपको याद होगा दोस्तों कि बम्बई के आए थे, बम्बई डिब्बा वाला पवन अग्रवाल। तो आज फिर से हमारे साथ एक बम्बई के साथी हैं और खाली बम्बई के साथ ही नहीं, आपने ध्यान दिया हो कि पिछले कुछ शोज़, हमारे पिछले कुछ सेशंस डिपार्टमेंट ऑफ एटॉमिक एनर्जी की कोलैबोरेशन से चल रहे हैं। आज फिर से हम एक बार डिपार्टमेंट ऑफ एटॉमिक एनर्जी के साथ हैं। हम धन्यवाद ज्ञापित करते हैं डिपार्टमेंट ऑफ एटॉमिक एनर्जी, टाटा इंस्टीट्यूट ऑफ फंडामेंटल रिसर्च को, कि वो हमारे साथ कोलैबोरेट करते हैं और हमारा मान बढ़ाते हैं और हमारे द्वारा सुझाए गए टॉपिक्स पर अपने एक्सपर्ट्स को हमारे साथ शेयर करते हैं। बहुत बहुत धन्यवाद डिपार्टमेंट ऑफ एटॉमिक एनर्जी। इसके साथ दोस्तों आज का टॉपिक है, जैसा मेरे साथी तन्वी ने कहा, शून्य, जीरो, नंबर्स की एक बड़ी खेल है। मैं नंबर्स के बाद थोड़ा सा बात करना चाहूँगा कि बहुत सारी चीज़ें हैं दोस्तों नंबर्स के बारे में आप सुनते हैं, पर शुरू में थोड़ा सा एक लाइट माहौल में बनाना चाहता हूँ। नंबर्स की सुप्रीमेसी लेटर्स के ऊपर बहुत सालों से मारी जाती रही है। नंबर कितने हैं? 10, लास्ट 0, 1 2 3 4 5 6 7 8 9 0. Letters 26. Despite of the fact that we have 26 letters, we have hardly have 2 million letters, 2 million words or so. How many numbers do we have? The sets of numbers lead to infinite. Even in the game of the English Scrabble, the letter numbers supersedes over the word letters. The numbers carry 11 marks, the letters carry 7 marks. So great, with this lighter note, we want to talk about numbers, and we have to talk today the king of the numbers, that is the number 0. I have Professor Mayank Vahia with me. So welcome Professor Vahia with us. Once again we thank you, and we thank Tata Institute of Fundamental Research for being our collaborator in this series very actively.
Thank you.
So दोस्तों जैसा मैंने कहा, मेरे दोस्त डॉक्टर मयंक वाहिया is presently the Dean, School of Mathematical Sciences at the Narsee Monjee Institute of Management Studies in Mumbai, where he is setting up an innovative undergraduate program in mathematical sciences. Professor Vahia got superannuation from the Department of Astronomy and Astrophysics, Tata Institute of Fundamental Research, Mumbai. Yes, India in October 2018. At TIFR, he worked on space-based telescopes that were flown on NASA's space shuttle, one Russian satellite, and several Indian satellites. Friends, we are going to talk more about these shuttles and satellites in Indian astronomy program. We have been doing it. Remember, in November 2021, we talked about Indian space program when Anil Bharadwaj, the director of Physical Research Laboratory, Ahmedabad, was with us. All these sessions are lying in our NCERT event section. If you see our website www.ncert.nic.in, and then you go into the event section, you will find all those sessions with us. In January 2022 also we had a session on Mission Aditya when Arvind Ranade was with us. We had another session. We are going to have another session on Mission Aditya soon, next, that is on August 18. I will introduce it later. So Professor Mayank Vahia is also an astronomer, and his efforts have gone into the astronomical space shuttles. Later Professor Vahia pursued his interest in the history of astronomy and science in ancient civilizations. All through his career, he was keen on student training and initiated the Astronomy Olympiad Programme in India. Recently, you might have heard that India has won a number of gold medals in Indian Astronomy Olympiad programs, Indian Mathematics Olympiad programs, Indian Physics Olympiad programs, etc., etc. Professor Vahia has been pioneer in establishing the Astronomy Olympiad program in India, of course. He has not only created and cultivated interest in astronomy in young students. Notably, Indian teams have performed very well in international events. We say it with pride. Dr. Vahia has about 200 scientific publications to his credit. Welcome once again, Professor Vahia. Now it is all yours. Sir.
Thank you very much.
Sir.
Yes, sir. So first of all, I want to thank Gagan Saab and NCERT for giving me this opportunity to talk to you all about 0. Now 0 is a very strange entity. 0 is an entity which represents nothing. And how do you represent nothing, why do you represent nothing, why bother about nothing is an important set of questions that we need to look at. The idea that an entity represents nothing itself is something strange, and you will be surprised how many cultures have sort of resisted the very idea of acknowledging something as being nothing. it elicits surprisingly strong emotions. So, for example, there are cultures that almost aggressively refuse to accept 0, and there are some cultures who found 0 as the most amusing entity, and we will see the difference between the two. As we will see, Indians are very quick and very comfortable with accepting the idea of 0, because culturally they were tuned to the idea of nullness well before the algebraic 0 came into being, and therefore to them null was a natural idea. Europeans, on the other hand, were aggressively against the idea of 0, because they did not like that idea of something being nothing because of various cultural reasons, and we will discuss those issues today. So, what is the importance of 0? 0 requires a kind of cultural orientation, and that is what I am going to talk about in the later part of my talk. 0 is natural to Eastern thought, and yet when you were taught natural numbers in the school, you were told that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, which is a European definition. European definition does not include 0 as a natural number. To Indians, in fact, 0 is a natural number. So, in Indian system, natural numbers begin with 0, 1, 2, 3, 4. While in Western system it begins with 1, 2, 3, 4, and that is more subtle than you would think as a quite casual thing. The Western philosophical thought, the idea that God existed everywhere means that there was nothing where there was no situation where there was nothing. God was always present, and given that strong influence of the church, the idea of there being nothing was always an anathema to them. So, Indian thought null was something that was real, viable and useful, and that is what makes it fun. That is what makes looking at these ideas and thoughts so much fun. In the present talks, I will talk about various ideas of null, how they were used, how they were invented, how they were in some sense discovered, and how they were made to very good use, and how eventually the humanity came to accept null for its importance. It required some amount of different kind of approach to life, and that is what I will come to. It is worth remembering that while science gives us ideas, it is culture that depends on how we react to it. How we are reacting to various situations, how we respond to various situations is not defined by science, it is defined by culture, and that is where the important difference comes in. We perceive or fail to perceive some reality and create alternative realities, even and ignore some of them completely, but that is our cultural perspective. From the 16th century to the present, we agree that Europeans have led the scientific revolution, but before 16th century it was definitely not the Europeans who controlled the narrative of science. It was Indians, the Arabs, the Chinese and several other cultures that had done phenomenal work in the growth of science, but those are stories for some other time. But science itself is very old. It is as old as in fact humans. In fact, it is older than the human race. Even our earlier cousins of Homo sapiens, the Homo erectus, probably made stone tools and understood how to break stones in order to make them sharp edges. So, inquiry into nature and manipulating nature to do something for us is what we call science and technology, and that is older than even the human race itself is. But how we react to various ideas that come up in science is what we are worried about. So, we are going to look at how 0 is molded by our experience with reality and environment, and how our cultural ethos make us look at this entity called 0, and 0 makes a beautiful example of this difference. So, the first use of zeros. Indians were not the first ones to use zeros. The earliest use of 0 in fact is in Babylonians 3000 BC, where they use 0 as a placeholder in arithmetic. So, if somebody had 5 sheep and they gave away all the 5 sheets, they were left with the number 0. They even had location based value system, they had calculations etc., where 5 plus 5 came out to be 1 and 0 and so on. Interestingly, instead of using the base 10 that we are all used to because of our 10 fingers, they used base 60. And 60 was a useful number to have, because 60 can be divided by 2, 3, 4, 5, 6, 10, 15, 20 and 30. So, if you had an entity and if you just took one half of it, you just divided by 30 and so on, and therefore, for mercantile purposes it was easier to use base 60, but they used base 60 instead of base 10. So, they were that creative in using number for commercial purposes, for mercantile purposes they were very good at it, but they stayed with that. They did not go and explore it beyond that. Initially they represented null as 0, so it was blank. So, if it was 2 plus 2 or rather 5 plus 5, then it was 1 0. So, 1 was carried over, but that 0 was left as blank, and that blank would create confusion in later reading. So, they replaced that with this little set of symbols that you see. These are the various uses of zeros that you see. Babylonians use 0, like I said, second 3000 BC, Mesopotamians at 0 600 BC, Mayans at 400 BC they were using 0, and you can see how complicated their drawings were. Khmer used 6th century AD. In Bakshali manuscript 224 BC or so, we actually see the first enumeration of 0 to 10 as all the numbers. It is worth remembering that in earlier literature, if you wrote number by speaking, so if you say 2003 for example, you do not need 0 symbol, you just need that number 2003, and therefore 0 would get implied. The explicit use of 0 in arithmetic and beyond is what makes all the difference. So, 0 in India, like I said, if you say 2003, you do not really need the number 0 or understanding of 0 and so on. 0 comes in when you start doing the algebra of 0 and the arithmetic of 0, and that is what we will look at. So, India is credited with 0 because India converted mathematics into a language. It is for the till then mathematics was something that was used by merchants for their arithmetic and nothing beyond that, and for that 0 was used commonly and 0 was used as a number, which was nothing great. What the Indians did was to define the entire language of mathematics. It has a grammar, it has a syntax, it has a structure, it has sentences, it has meaningful sentences, it has meaningless sentences, it has grammatically wrong sentences, it has grammatically correct sentences and so on. All that entire algebra of mathematics was created by Indians, and algebra of 0 was an important part of the story. And if you just had to explain what is mathematics, language of mathematics is a difficult phrase to give, but the idea that crediting India with 0 makes the same point in a much more compact manner. In 7th century, Bhaskara for the first time gives you the complete algebra of mathematics, and I will show you that a little later. In principle, that was enough to give India the credit for giving 0 to the world, but the important thing is this language of mathematics that was given. Later on, good 3-4 centuries later, Newton would eventually convert that algebra into a useful algebra for physics and mathematics. So, for example, I will show you the Kerala school of mathematics went to limiting value theorem and even to some extent to differential algebra idea, but they did not use it in physics. That was used by Newton. But the idea that there is some mathematical structure called differential equations and limiting value comes from within the Kerala school of mathematics. So, why did India do it and why did others not do it? The reason is that India was in love with this 0 or shunyata or null. That shunyata and null was such an ingrained idea into Indian philosophy that we had no problem looking at 0 even in mathematics, and that nullness is what makes it so important, and that is what I am going to spend my time on. So, let us look at the Indian 0. The first appearance of Indian 0 actually is in religion. If you look at the famous Rigvedic verses, I will come to that in a minute. The idea that the universe was created from null, and therefore, the God does not prevail everywhere, because what was at the beginning was null. From there, as Narsee Sukta says, out of his own love the world was created by the great creator who is never worshipped. The Brahman, the great Brahman who creates the universe, is not worshipped because he remains in that null entity, and that is where the first idea of null becomes so much comfortable to Indian thought. He is non-religious, he is not manifest, he is null and the ultimate null of all universe. And then we have this famous Purnat Purnamidam Purnamaditya vagare, where we talked about completeness into completeness and so on. So, 0 was seen as a complete number. So, you have Narsee Sukta, a very famous verse from Rigved, which says, in the beginning, at first there was neither being nor being, there was neither air nor sky, not yet sky beyond. So, what was wrapping where was this unfathomable void? And then the verse keeps going on, and it says that there was neither death nor a whole bunch of neithers were there, neti neti, neither this nor that. And it even says that who really knows, who can presume to know, and this is even gods will not know because gods come after that. So, the original universe did not even have God, there was nothing, there was nullness. And then they wonder who can tell you who has done that, and they say maybe he who surveys the highest heaven, maybe he surely knows, and then they wonder maybe even he does not know. So, this idea that non-knowability is a part of knowledge was something that gets inbred to us right from Rigvedic period itself, and that tradition of handling null continues for a long time. Then we do meditation. In meditation, the first thing that we talk about is that we should try and blank out the mind. Thoughts are not primary. It is a non-thinking stage of the mind that is so much crucial to the development of mind and understanding and our context to the universe and so on. It is fundamentally different from practices of elsewhere, where the idea is to not so much think, but the idea is to prevent the brain from thinking, so that that nullness that is so inbred into us takes over and gives you this connectivity to the universe. The idea of blanking the brain itself is common. In the we know that early Vedic people or people who were nomadic in their lifestyle, but they needed a sophisticated language in order to be able to carry and convey these ideas over large distances without the burden of writing and written documentation, which could not be carried. So, to preserve these ideas, they come up with this beautiful language of Sanskrit, which is grammatically precise and which preserves its creativity even when spoken across time and space. So, for example, even if today if you may be a Tamil speaker in Tamil Nadu or a Hindi speaker in UP, but when you recite Rigveda, it sound exactly the same. And that is where the genius of this language comes in, and within that are built in multiple ideas of null. There is rhythm, there is music, and there are also null. So, for example, Sanskrit has a very precise way of defining how to carry forward ideas. So, chand is an obvious idea where the rhythmic recitation of words means that you will not be able to put one word without out of place without having an error. So, that chand is one, but there are also 6 levels of combinations that are done to test whether what you are speaking is correct. Sandhi is a very powerful tool that Sanskrit uses, and that preserves information much better, and I will give you an example of this. And therefore, India has eventually would end up with a script where this Sandhi would become critical, and we have the only Abugida script or alpha syllabary script in India in the world, where vowels and consonants are combined to give you a letter. Earlier Gagan Sahab was talking about 26 letters of English. Hindi has 32 letters if you only go by ka, 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 kha, ga, ga, but if you take ka, ka, ki, ki as different words, not words, different syllabi, then you end up with some 490 different syllabi for Hindi language, because o, a, e, each would be different, and that compacting is what makes the Sanskrit language so beautiful. And then Brahmic set of scripts are all of this kind. Panini uses 0 the most effective. Now, Panini himself says that, look, I am not the creator of this knowledge, I am somebody who is simply compiling this knowledge, but he compiles his rules of Sandhi beautifully. In compilation of Panini, there are 6 ways of nulling a word. One is non-hearing, you do not hear that word that does not exist. Non-pronunciation, a letter that exists is not pronounced. Not available, the word is just not kept there. A word that may be not in existence at all, abhava. And then you have varna or loss of sound, where a particular word may exist, but it is not pronounced. And that is what is the second idea, set of ideas of null. And I will give you an example. I have a friend called Vategaonkar, and I hope he does not mind my using his name, but Vategaonkar is a Marathi word which means Vatet yenara gavat rahnare. In Hindi it means raste mein aane wale gaon mein rehne wala. Or raste mein aane wale gaon mein rehne wala becomes Vategaonkar because so many words are eliminated. Vategaonkar, Vat is simply a first begin, but Gavat is eliminated simply. It simply says road, village, resident, and within that there is a whole bunch of conjunctions. To from Vatet is Goa, and Gavat becomes lost sound. Yenara is completely made not available in that sentence. Rahanare is non-existent. Gavat is also not has resistance, and eventually the whole thing is compacted as per Panini's rule to give you this word Vategaonkar, which tells you a whole sentence which says raste mein aane wale gaon mein rehne wala becomes just one little word, and that compactification has so much of nulling of sounds and words that it requires very precise grammar to make sure that you do not get it wrong. Sanjay, of course, is the first name of my friend, and therefore that is an easier word to pronounce. The same thing you can do in raste mein aane wale gaon mein rehne wala. I am not so sure I want to go through the whole thing, but this is how it goes. May disappears, aane wale disappears, rehne wale disappears, and so on, and eventually you get this compactification which is to precise grammatical rules. It is not a random thing. Then there is a linguistics, Panini has linguistic 0 like I said, which employs various grammatical rules and so on. The only equivalent in English that is easy to find is that 3 times is called thrice, but otherwise English does not use this compactification. There are definitely no rules as to why 3 times becomes thrice. Lopa is a form of nulling which is very common in India, but again defined very precisely by the rules of Panini. Then there are mantras. If you go look at Samved, for example, there are mantras that have words which have no dictionary meaning at all. They are there to give you the rhythm, they are there to give you a blankness of mind, and they are designed to create a kind of concentration and focus that you can see in religious sounds, but there is no word to it. Everything does not have to have a meaning. There can be null is an idea that is very common. So, for example, if you look at 2nd century BC idea of what is knowledge, it is interesting to compare. Modern idea says that sense perception, reason, emotion, faith, imagination, intuition, memory and language are all ways in which you can get the knowledge. Vaisheshika, Kannada in 2nd century BC says no, only perception, inference, analogy and derivation from circumstances, non-perception, something that does not have, and the verbal testimony of reliable person are all there. 1, 2, 3 and 6 are included in Nyaya system also, and Vaisheshika, therefore emotion, faith, imagination and intuition are not included in the way you can get knowledge. So, the very idea of knowledge and what is knowable is very different in India. Vaisheshika is a very famous book of physics, 2nd century BC. We of course do not have time to go through it, but it talks about the 5 physical elements, solid, liquid, air, fire and so on. It talks about Atma as a source of life, and then it talks about Mana as the source of intelligence and so on, and then there are concepts of Parmanu and all that. Non-existence in Vaisheshika is also very important. So, there is a priori non-existence, some property did not exist. Some properties can get destroyed, like color can get destroyed if you mix red, white and red, yellow and blue, you end up with white and so on. So, some properties may be not non-existent, some may posteriorly afterwards may not exist. There may be reciprocal non-existence. If A exists, then B is not there and so on, and then there are absolute non-existences. So, again the basic idea of what happens in the physical universe, which is what Vaisheshika is, it is a physics textbook of 2nd century BC, talks about this idea of disappearance or non-existence or ceasing to existence. So, null in that science is very common. Then Brahmagupta is the first one, or rather the post Aryabhata, the post Siddhantic period, by definition the Siddhantic period 500 AD talks about converting mathematics into language. Aryabhat, Bhaskara, the whole series of some mathematicians all the way till Kerala school 13th century were obsessed with the idea of mathematics as a language. What can you say in language, and what does various statement in language mean, and that is where it is. And Brahmagupta for the first time writes down for us the arithmetic, the algebraic meaning of 0. What does 0 mean in algebra is something that he defines for the first time. So, he gives what is 0 in an equation. Okay. So, Indians did not, in that sense, the arithmetic sense, we did not invent 0, but we understood what 0 meant. So, in Bijaganita it is said, for example, that 0 plus x is equal to 0 or x plus 0 is equal to 0, it is commutative, x minus 0 is 0, if you multiply something with 0 it becomes 0 and so on, and you can't divide by 0 and so on. So, the basic set of algebraic equations, the so called language of 0 is given to us in 7th century by Bhaskara, and that is why he gets that is why India gets the credit for having defined the very idea of this mathematics. Later like I said, Indians were the ones who invented the language of mathematics, and that made all the difference that it does. Within this work we can see very early ideas of differential algebra, and there are some suggestions that in fact Kerala school went all the way till differential algebra. The Boolean logic of binary systems etc. is there within this system. They were not ideas that were developed, they were not ideas that were understood properly, but subsequently the other developments in the language of mathematics would bring out these other features of mathematics that we today talk so easily, are there rooted in these early works of Siddhantic mathematics. The very foundation of what the idea of mathematics as a language comes in. And if you think about it, mathematics is a language. It is a language like any other language, except that it is very precise and very grammatical. It so happens that when nature speaks, she prefers to speak in the language of mathematics, and that language is compact, precise and very, very informative. So, you can use that compact language of mathematics to understand a whole host of things which normal language would not have given, which English language would not have given. For example, if I take a pendulum, it says it oscillates in English language. That says nothing more than the fact that it oscillates. But if you write down the mathematical equation of it, you realize that from the pendulum watch you can make a wristwatch and so much more, because it is just anything that obeys that equation. Once you have the mathematical equations of a movement of a pendulum, you have a very versatile mathematical equation, and that is obeyed by a little crystal in my watch, and therefore, that crystal can also be used by to make a clock exactly like my pendulum clock. That generalization, that power that mathematics has, and the fact that nature prefers to speak in mathematics than any other language itself gives mathematics the power it does. And Siddhantic period in India, 5th century AD, is when humans first accept mathematics as a language and development on that. And one of the most curious entity in that algebra of mathematics, of course, is 0, and Bhaskara, 7th century, for the first time writes down the very rules of using 0 in this mathematical language, and that is why they say that India gave 0 to the world. There are other interesting asides where 0, for example, is null set and so on, but I am going to sort of skip on that idea, but this idea of limiting value theorem and so on is something that is there in the early algebra. So, 0 in multiple forms is India's contribution to it. 0 is a null entity that created the universe. The universe was not created by God, the universe was created by an entity about which nothing can be said, and nothing existed when that creation came into being. 0 in meditation, like I said, is very useful to give you that connectivity to the universe. Asana is only one part of yogic practices. Meditation is an important part of the story, because it is meditation that gives you that connectivity. The idea of having a brain that is at null point is what gives the power, and that gives you the familiarity with 0 and nullness, which eventually we use in defining that same concept of null in mathematics, in the language of mathematics. Grammar uses 0, like I said, very effectively. The nulling effect of 0 is used in order to help you understand, speak in a compact manner, speak with minimum words and speak with minimum error. So, Panini and others use 0 in language or in Sandhi very effectively. Similarly, there are mantras and there are recitations in Samved onwards, which are words which you would not have dictionary meaning, but they give you a sense of wordless rhythm, which is useful in a variety of ways. Vaisheshika, like I said, uses mana and atma for life and intelligence, but it has a whole bunch of zeros in that. So, for example, it says the universe something cannot be infinitely small, because if it is infinitely small, I can take a small piece of rock and keep cutting it until I get enough material out of it to make a mountain, which is not possible. So, the first idea of contrary definitions, etc., as a matter of proving is something that is there in Vaisheshika, and Vaisheshika says that because you cannot make a mountain out of a piece of stone, obviously there is a smallest entity which he calls Anu. And that Anu, of course, is very different from the way we use the word Anu today. There was no periodic table, there is no idea of elements and so on, but the idea that there is a smallest entity for everything is something that comes from Vaisheshika. Anu, like I said, is defined in Vaisheshika, and then the great mathematics, the language of mathematics, and 0 in the language of mathematics comes from Bij Ganita and so on. 0 then started out as Shunya, becomes Sifr in Arabic, and eventually becomes 0 in Europe. It is the same transition, but it takes 400 years to do that. The Arabic mathematicians who come to India very quickly realize the beauty of this algebra, and they in fact very conscientiously write down saying that this new mathematics that is coming from India is really interesting and worth studying. The Europeans get it from the Arabs, so they call it Arab numerals, but Arabs themselves are very honest in claiming that they learnt it from the India. So, the idea transfers, but 0 and Europe had a problem, and that is what I am going to talk about in the remaining time that I have. So, 0 in science represents neutral, and that neutral can come in a variety of ways. It can come in balance of forces in physics and related subjects. It can come in particular properties, so pH neutral and so on kind of ideas come in. 0 also comes in as a balance of forces. So, for example, if you do your electronics experiment and you know that if equal amount of current is passed through, then central point gets 0 current and so on. Biology, it is a balance of stresses and signals, and therefore, things remain in equilibrium. Digital electronics, very low voltage is considered 0. So, essentially electronics has 0 and 1 as the binary, the digital electronics has 0 and 1 as binary, and 0 voltage or very small voltage is called 0, while 5 volts or around 5 volts depending on the electronics you talk about is considered as 1. So, the very idea of 0 changes. Nature has 3 very precise zeros which cannot be changed. The first 0 is the mass of a photon, the mass of the light particle. It is numerically absolutely 0 in the classical linguistic sense of the meaning of the word 0, mathematical sense of the word 0. Photon cannot have a mass, because if it has mass, then it must travel at velocity less than velocity of light. 0, the charge of neutrino we know is an absolute 0 in the very classical sense of 0 again. And the third 0 that is absolute is the so called 0 degree Kelvin temperatures, minus 273 degrees centigrade, where all motions cease, and there is no such thing as minus negative Kelvin temperatures. At 0 everything freezes and is done. So, there are these 3 great zeros in science which were all later realized. 0 of perfect value vacuum of physics is very, in fact 0 of vacuum, it does not exist. A perfect vacuum is one of, we have found to our surprise, is one of the most active places in the universe. It is in this perfect vacuum that fluctuations of that vacuum create a whole bunch of universe that we see it. Black holes lose their mass because of vacuum fluctuations, and polyelectrons, positrons get created. Quantum mechanics behaves in a particular manner, but perfect vacuum is not a 0, and that is one of the curiosities of modern science. Then there are lots of artificial zeros where force balance gives you 0, but we will not talk about those. In astronomical, zeros are if you want the points of gravity of black holes and so on, and an object where the speed of light is 0 gets into all kinds of troubles. Then we also talk about errors in zeros, because except for these 3 fundamental zeros, really there are only approximate zeros in the universe. 0 in the 20th century is a very different century, especially in the second half of the 20th century and the modern century. 0 in electronic circuits, like I said, is low voltage or high voltage, but in digital electronics, especially if you have software in the this thing, 0 becomes a number. So, for example, in the classical arithmetical sense, 0235 essentially was 235. And in Excel sheet, if you try to type a number 0235, it will automatically convert to 235, because leading zeros have no meaning, and after decimal, of course, the subsequent zeros have no meaning. But in computers have changed that, because computer level considers 0 as the first level. A number like 0345 can be a password, or 0345 can be your PIN number if you want. A leading 0 suddenly picks up a value which your original arithmetic did not have. The language of mathematics still does not allow you to give 0 a value. The way pin code, IPIN or your credit card pin, etc. gives you. So, in that sense, computer science has changed the very nature of 0 against what it was in the classical mathematical sense. So, it is not, it is a different 0 from the 0 of mathematics, or it is a 0 of Panini, it is different from the 0 of others, because now 0 becomes an eligible entity. And of course, in set theory, when you talk about a null set that has nothing, is different from a set that has 0 as an element. There again, for the first time, 0 becomes an entity of its own, and then of course, computers have spoilt everything in some sense and made everything even more amusing than what it does. Leading zeros have acquired value in the late 20th century and early 20th century. These are not, so in that sense 0 is not a number there anymore, it is just a label of the 10 possible labels you have. So, 0 has changed its structure. The bottom line is that 0 has multiple representation. It is there in philosophy as the great creator who is null. It is in grammar, where we use it to combine words in a manner where the evolution of that value is consistent, uniform, everywhere understood, and irrespective of how you pronounce your personal words. When you pronounce Sanskrit words, you get this beautiful consistent definition. And Sanskrit also, Rigved, Samved for example, uses sound without value or without grammatical meaning as a null sound to give you that structure. Mathematical 0 of course is a beautiful entity, arithmetic 0 is a trivial thing, but algebra of 0 is a very fascinating subject. Science then gives a completely different to 0, where null balance of forces are your zeros for you locally, and globally there are only 3 zeros of photon mass and so on. And then computers have come and converted that 0 into an entity which is used like any other numbers. It is just 0 for any given location in a pin you have 10 possible values including 0. So, leading 0 once again for example has a meaning in computer science. So, the same entity of null representing nothingness has a different perception in philosophy, has a different perception in grammar, has a different perception in mathematics, has a different perception in science, and has a different perception in computer science. Everywhere that same entity representing nothingness has different meanings. I just want to, in the last 10 minutes that I have, I want to talk about Europe and 0. Why did Europe resist 0 so much? To Europe, the very idea of 0 was unnerving and they could not accept that very idea. To them everything was one, the great creator was everywhere, and therefore there could never be a place where there was nothing, because the great creator spirit would always be there. And that idea of the great one being everywhere was so strong that even though Indians give the algebra of 0 in 5th century or 7th century AD, the Arabs pick it up in 7th century AD, the Europeans do not accept it till 13th century AD, and in fact they are Europeans are explicitly banned from teaching 0 and the algebra related to 0 by the church. By the time the 13th 14th century comes, the algebra of mathematics with using Indian mathematical system and the language of mathematics becomes so much that the learned men of mathematics eventually force the church to accept that 0 can be taught. But their philosophical objection to 0 remains even today. You can see, for example, black hole is a null point in the universe where everything becomes null, but we call it a singularity. The idea of calling something 0 still scares European intellectual creativity. Linguistics 0 gets it's not something that it accepts very easily, and that differences of singularity and null point are something that you see even in 20th century. But they do something that Indians never did. So, Indians write a whole bunch of mathematical series and sequences and so on, and wonder what happens where the values go and what happens if it is 0 and so on. But the idea of f(x) equal to 0, a function equal to 0 and then solving it, is a European addition to this very idea of a different branch of mathematics. So, they develop a whole different branch of mathematics when they talk about f(x) equal to 0. That is something Indians did not do for whatever reasons. So, India and Europe vary in 7 different ways. There is a tradition of worship that is the great one is worshipped against the null that is unworshipable, but the greatest, and nobody, not even gods, can tell you about them because he precedes the gods. Or similarly, disposal of mortal remains the way we dispose mortal remains. Rigveda itself has some 6 different ways of disposing the mortal remains of the dead, including leaving them to nature and so on, but essentially cremation now is a very standard, where there is essentially the body is nulled down to 0. Tradition of oral transmission in India is another unique thing, and therefore we needed this Panini's grammar to ensure the precision of knowledge transfer. Rhythms, like I said, can be null. The definition of what is knowable itself. So, for example, Panini when Bhaskara etc. define the movement of planets etc., they put in a little flag saying this is to the best of my knowledge and belief, and that it is for subsequent generations to keep on checking whether my knowledge and belief were correct. The idea of absolute knowledge does not exist. The idea is relative and therefore creative, and there are differences of inductive thinking and deductive thinking and so on, which I do not want to go into it. But meditative rather than argumentative approach is what still underlines Indian way of doing things. Tradition of inductive thinking rather than deductive thinking makes a lot of difference, and I have a little slide on deductive and inductive thinking. The inductive thinking is by positive example. So, something is happening. If there is smoke on the mountain, then I know there is smoke when I light fire, and therefore there must be fire like that. The idea is to inductively compare what I know with what I see, to deduct that the two must be, to realize that the two must be different. And that, for example, is very different from the way Europeans would do it, where they would say that there are a set of rules nature must obey and all that. So, there are subtle differences in this. So, for example, if I see I know the fire in the kitchen produces smoke. So, if I see smoke somewhere else, I know that there is fire. The reason that does not it does not proceed from particular to particular, but it goes from this comparative study. Deductive logic on the other end insists on universality. So, if A is true, then forever A is true, and that is something that is a very powerful tool of demanding natural consistency. And therefore, deductive sciences took us through the Renaissance period and all to the modern technology. On the other end, inductive approach is a little more defensive in its very nature, and both are of course open to natural challenges and all that. To give you an example, there is a very famous deductive scientist Paul Dirac, who says that it is more important to have beauty in your equations than to agree with experiment. He says my equations are smarter than me, because there is a confidence that once I have written down something in the language of mathematics, that now sentence is independent of who spoke the sentence. The other extreme is an equally famous American scientist called Feynman. And Feynman says that I do not understand explanations, I worship phenomena, something looks beautiful and seems to work that way. He says I do not tell nature what to do, I do not tell nature that this is the equation I have written and you better obey that equation. He says I do not do that, nature just tells me that I obey this equation. And a very great deal more of truth can be known than can ever be proven by mathematical deductive techniques. Feynman is the first, makes that statement beautifully. And then the others who talk about how inductive logic is more thought provoking than deductive logic. So, general comments, rational and intuitive were not divorced in India. So, Europeans, for example, right from Aristotle time, talk about logos and mythos, logical things and mythological things, and then how they evolve. Indians make no such difference right from the beginning. The open-mindedness of Indians therefore permitted zero to be sort of explored in a manner which West did not, and eventually West would accept it with great reluctance. The awkward state of affairs continues, like I said, even till today, where zero is very reluctantly accepted outside the academic circles. The same case can be made for infinities, but I mean I neither have the time, and Gagan Sahab I am sure does not have the patience to listen to me talk about infinities, but infinities are similar set of problems. Would inductive science have gone anywhere beyond what it has? It is difficult thing to answer, but there are a lot of complications why inductive science eventually did not go very far. But for example, Aryabhat tells you the rules of planetary motion, and he has these epicyclic motions and all that, similar to what the Greeks had, but it did not lead to the rule of law of gravity which Newton would discover. So, even though mathematical rigor was not alien to Indian thinkers, they essentially were sort of limited by their deductive thinking. So, the bottom line is that science prides itself in being cultural, independent and absolute, but it is not. How a particular scientific idea is handled depends on cultural context and cultural sensitivities, and therefore, each cultural sensitivity will give you different insights. I will tell you, even in 21st century, I have heard a great American scientist say that look, if he is looking for PhD students, if that's true, that particular project for which he is looking for a student requires a lot of hard work and a lot of mechanical rhythmic work, etc., he would take a Chinese student. But if it is a project that requires a lot of thinking, lot of introspection, lot of independent creativity from a student, he would take an Indian student, because as Amartya Sen says, Indians are used to being argumentative, dialoguing, thinking, meditating, all that is very natural, because it is cultural naturalness to us. So, even today, even in 21st century science, it is different to be a student from India than to be a student from China, for example. And that is where the complexities of that situation comes in. Uniqueness produces unique perspectives. So, I want to thank all those people who helped me prepare this lecture, and to NCERT for giving me this opportunity to come and talk about zero with you today. Thank you very much.
We should thank you, sir, for being a part of this program and for explaining all these things in much detail, be it the concept of zero, be it the null concept that was there, and the Sanskrit language, how it gave the 0, and a lot more. So we have a few questions for you, shall we?
Sure.
Okay. You said in one of the slides that the theory of knowledge is very different in India from the West. So can we define it as right or wrong? And if the theory of knowledge was different back then, is it still evolving?
Theory of knowledge is definitely evolving, and rather than right or wrong, what happens is that when you miss, for example, so India, for example, does not allow imagination as a way of creating idea. On the other hand, generalization of ideas, the deductive method of Europeans, comes because Newton says that, look, just as an apple fell on my head, maybe even the moon is falling on the earth, and that is something that Indians would have done. But then to go from there to write down the equation of gravity is something that we would not have done. So there are pros and cons, and now of course we know how acquisition of knowledge is so much more complex, and therefore rather than being right or wrong, it's a question of cultural approach to a particular set of issues, and each of them has had their own power, each of them has their own limitation. The deductive approach of Europeans in the early part, in the early Greek period, etc., did not go very far because they did not have the knowledge base that inductive sciences and the Arabic work and the Indian work would produce, on the basis of which in 16th century, when they go back to that approach, they can do lot more because it is based on the knowledge that was developed in the inductive methods. So they are more complementary rather than competitive.
Okay, all right. So there are two terms, astrophysics and astronomy.
Yes.
So these two terms, are they different? Are they similar? In what sense?
In fact, there are three terms: space sciences, astrophysics, and astronomy. Space sciences is technology. It is engineering. It is just the technology of going to space. Going to space may mean going to Pluto and going to outside the solar system and so on, but it is still technology, and it is a field of engineering, and it involves rocketry, it involves satellite, involves technology that is reliable, a whole bunch of things, moon landing and everything is part of that story. The second one is astronomy, which is something that is involved directly with observation. Look at the sky, see how the patterns are changing when comets come in, etc., etc. Astrophysics is an interesting subject because it takes you physics that we see in our labs, the physics that we are used to understanding with your laboratory, now insisting that physics has to be consistent, and therefore that physics that we see in our lab is also true for what is happening on the sun or the stars or the universe as a whole. So astrophysics is the subject of mapping this physics that we understand on the earth and mapping it to the universe to see if universe also obeys this consistency. And the beautiful thing is that the universe obeys all the rules of science. The problem with nature is that once she obeys one rule at one place at one time, she has no choice but to obey that rule at all the places at all the times. And therefore that allows us to map the physics that we see in our lab to the physics of the working of the whole universe, and that is where astrophysics comes in. Astronomy is something you can do at amateur level also if you want. Astrophysics requires a good training in mathematics, physics, and astronomy.
Sir, now please allow me to get in.
Sure.
Sir, yes, indeed, 0 is a label.
Correct.
You have explained it. 0 is not merely a number. 0 is being considered differently in different contexts and by different people. You talked about the precision in Sanskrit.
Correct.
So how it evolved? It evolved it came directly by the virtue of somebody speaking it to us, or it also evolved because the Prakrit is considered to be older than Sanskrit. So how this precision has come?
No, the Sanskrit precision comes from the fact that you are by lifestyle nomadic. You are moving from place to place. You want to carry your knowledge and carry it with high precision so that it does not get contaminated by people not understanding the language also. A lot of people who will carry your knowledge for you will not understand the knowledge they are carrying. So the idea is to make the spoken word so precise and so difficult to change that even if you don't understand the meaning of the word, as long as you have learnt it and passed it on to future some generation, somewhere down the line some generation may be able to make sense of it. But there should be no error in transmission of that knowledge. Sanskrit's precision comes with its obsession to make sure that knowledge is transmitted without corruption, even by people who do not even understand what they say.
This is the point. This is the point to probably say you made it a point. Idea of mathematics as a language.
Correct.
Narrated about it. Different people see mathematics differently.
Correct.
I see as precision. I see as reasoning. I see is as a abstractness.
Correct.
Many people see it as a many have the algorithm, etc. The computer
Correct,
science has
correct.
really changed the way mathematics was
Correct.
done. People like me consider probably the mathematics is the first thing which a child starts learning
Arithmetic,
through
yes.
pattern recognition.
Correct.
Through pattern. So I consider patterns as recognition of patterns, the recognition as a part of mathematics, not as a part of anything else.
Yes.
How do you see it at?
Okay, so mathematics has the same obsession as Sanskrit does in passing on
Yes, this is-
information with precision. So mathematics is a language that is considered difficult because it is so precise. It does not allow you any. You can write poetry in mathematics. By all means, you can write, and there are some very good poets of mathematics. But the precision of term remains. That is one issue. Second issue is that we realize that nature speaks in mathematics way beyond simply arithmetic. So, for example, our very idea of beauty has symmetries built into it. Okay, we consider something to be beautiful if it is symmetrical. It is very rarely that non-beautiful things are non-symmetrical things are
yes,
considered beautiful, and that is ingrained into us. And so, for example, there are experiments where you take a 7-8 month old child who doesn't understand your definition of anything, doesn't know language, doesn't know anything. You project beautiful faces in front of that child, and the child will remain mesmerized. You start showing non-beautiful things, and the child gets distracted. Even the idea of beauty and symmetry is hardwired into our brain, because that is the first rule of judging whether somebody is genetically fit or not. So, the very idea of fitness comes from the idea of symmetry. I mean, modern education is modern education, but for example, in jungle environment, how do you know amongst all the genetic people you have who are the fittest? So, symmetry is the first rule, and that symmetry is built into our brain. So, even a 6-7 month old child will instinctively know what is
Even
symmetric
just after the
and
birth,
beautiful.
even just after the birth,
That's
you
right.
can have
That's right.
discussion
Yes,
on that.
exactly.
You talked about, you hinted, you didn't say those words, however, but you hinted about finding the orders in chaos.
Yes.
You find, so now you were making 3 basic zeros.
Correct.
Mass of electron, sorry friends, mass of a photon, I mean, charge on a neutrino,
Correct.
zeros.
Yes.
You talked about the third zero, 0 Kelvin.
Correct.
But the Bose-Einstein condensate material, if you
Yes.
consider it, translate into the physics or in the science.
Correct.
So, Bose-Einstein condensate material is considered to have that as if the energy contained by the atom,
Correct.
by the system at the 0 Kelvin temperature or
Correct.
towards the 0 Kelvin
Towards.
temperature. Experimentally, we know about the mass of the photon and charge on the neutrino.
Correct.
So, though we have reached very close to temperature 0 K through laser fusion experiments, etc.
Correct.
Laser inertial confinements. So, how do you see that 0 Kelvin, can it be achieved?
0 Kelvin will always, we will go closer and closer. So, the closest we have now been to a 1 micro Kelvin temperature.
1 micro Kelvin, yes.
We will probably be able to go to nano Kelvin, but the absolute zero of absolute will never be achieved. It will always be
Yes, this is
asymptotically
what-
zero. Yes. The second interesting question you raised.
So, how
is-
if you say that it is difficult to reach there 0, probably not in consumption.
Okay, so you refer to this laser confinement.
Yes.
So in principle, I can take an atom and make sure that it is held so tightly that it does not move.
But this is against Bose-Einstein
in
condensate
that
process.
sense, it is an absolute zero temperature because all motions are ceased. But in the very process of achieving that, you are doing so much work outside
work, yes.
that absolute zero will not come in.
I see.
So it's a global situation. At a location, at a particular atom, I can make it move zero.
So, I am still confused how to understand 0 Kelvin as a fundamental zero.
The simplest thing to do is to say that look, atoms move. Okay, so in the air, for example, right now there is so much oxygen, nitrogen, etc. Those atoms are moving. If I keep cooling it, the amount of motion will become less and less and less.
That I understand.
But
Towards
eventually,
I
zero is where nothing moves and nothing happens. It is the ultimate state of where nothing happens.
Interesting story, Dr. Saab. Bada maja aaya. I wanted to talk to you. I would talk to you a little later about the Vate Gaonkar story.
Yes.
Yes, that's great. In fact, we learned Maharashtra in the sense because the kind of surname we think of, it has a finite probability to be found therein.
Kar is a very common surname.
Yes, thank you very much. Thank you very much, sir. And we once again thank Department of Atomic Energy for collaborating with us. Tanvi.
Thank you so much, sir. And thank you for bringing Dr. Mayank Vahia here. And it was a pleasure having you, sir. Thank you so much. So, we are wrapping up this particular program. I really think that you enjoyed this conversation because it has a lot and a lot of knowledge. That's what the students of science require at the moment. Please watch it again on NCERT Official in case you have missed it. Next program is lined up on 18th of August. Let me just show you that on 18th of August, you'll be able to watch our session 60th of this webinar series, Listening to Learn. The topic of discussion would be Reaching for the Sun, the Aditya L1 mission of ISRO. It is going to be a very important program. So, sir, would you like to say a word?
दोस्तों, बड़ा important program है. इंडिया का L1 मिशन शुरू होने वाला है. बहुत जल्दी ही इसके बारे में आप खबरें सुनेंगे. प्रोफेसर दुर्गेश त्रिपाठी आयु का पुणे से हमारे साथ जुड़ेंगे. और ये प्रोग्राम मैं आपको जस्ट रेफरेंस के लिए बता दूं, इंडियाज L1 प्रोग्राम इज टू स्टडी द सोलर कोरोना, सोलर फ्लेयर्स एटसेट्रा. सन की प्रॉपर्टीज़ को पढ़ने के लिए, समझने के लिए ये प्रोग्राम हमारा भेजा जा रहा है. स्पेस में L2 मिशन, L1 मिशन में जाकर रहेगा. इसके मिशन के बारे में दोस्तों हमारे साथी आनंद ने बात की थी जनवरी 2023 में, जो कि इंडियन इंस्टीट्यूट ऑफ स्पेस साइंस एंड टेक्नोलॉजी से हमारे साथ जुड़े थे. ये सारे के सारे, जिससे मैंने प्रोग्राम के शुरू में कुछ रेफरेंस दिए थे, आप सारे प्रोग्राम को दोबारा से देखिए. आपसे प्रार्थना है और आप रेफरेंसेस को देखिए. इसके साथ ही थोड़े दिनों के बाद हम चंद्रयान पर भी एक प्रोग्राम लेकर के आएंगे, जबकि इसरो मुंबई बेंगलोर से हमारे साथ डॉक्टर A.K. अनिल कुमार जुड़ेंगे. धन्यवाद.
बिल्कुल. तो इस सीरीज़ में आप सभी के लिए बहुत कुछ है देखने के लिए, सुनने के लिए और समझने के लिए. तो ये प्रोग्राम्स हम लेकर आते हैं एक महीने में 2 बार, फ्राइडेज़ को ठीक सुबह 10 बजे NCERT ऑफिशियल हमारे प्लेटफॉर्म पर. फिलहाल ये कार्यक्रम हम यहीं ख़त्म कर रहे हैं, पर पूरे दिन में आप सभी के लिए बहुत सारे प्रोग्राम्स हैं अलग अलग सब्जेक्ट्स पर, अलग अलग टॉपिक्स पर. तो उन्हें देखना बिल्कुल मत भूलिएगा ई-विद्या चैनल्स पर. अभी के लिए आप इस कार्यक्रम को देखिए और सवाल या कोई भी फीडबैक या सजेशंस हम तक ज़रूर पहुंचाइएगा. और जाने से पहले एक जानकारी देना चाहेंगे, NCERT की किताबें अगर अभी तक आपने नहीं खरीदी हैं नए एकेडमिक सेशन 2023-2024 के लिए, तो आप उन्हें ज़रूर खरीदें. या आप PDF वर्जन डाउनलोड कर सकते हैं NCERT दीक्षा या ई पाठशाला की वेबसाइट या उनकी मोबाइल एप्लीकेशन से, या फिर आप सेल्स काउंटर से खरीद सकते हैं सुबह 9:30 बजे से 6 बजे तक, जो मौजूद है नई दिल्ली, बेंगलुरु, अहमदाबाद, कोलकाता एंड गुवाहाटी में. इसके अलावा अगर आप वेबसाइट से ऑर्डर करना चाहें तो ncertbooks.ncert.gov.in है हमारी वेबसाइट. Thank you so much once again for being a part of this program. It was wonderful and we'll be coming up with more sessions very, very soon. Thank you. Take care. Have a great day ahead. I'm Tanvi Khurana. I'll take a leave of you. Namaskar.